In this video, we are going to look at a strategy for calculating the perimeter. The perimeter is a length measurement. It is a measurement of the length of the boundary of a 2D shape. If we look at this strategy is called pushing the boundary. If we move the boundary of our shape outside or further out, we can calculate effectively the perimeter of 2D shapes. So we have a cross here and we have a square. If we push the boundary of our cross out, we know that we can make a square, and it becomes easier to calculate the boundary or calculate the perimeter. I'm going to take you through this strategy right now. The first thing I would do is I would visualize moving the yellow lines further up to make one straight yellow line, and move the blue lines down to make one horizontal line at the bottom. Then we take our red lines, our vertical red lines, and we move them out to the right hand side. And then we take our green lines and we move them out to the left hand side to make two parallel lines. As you can see, now we've pushed the boundary out. We've pushed the boundary out to change our shape to a more user-friendly shape that we can calculate the perimeter. We can see that the two shapes provided are the same perimeter, have the same perimeter. Our cross has now become a square because we've used the strategy of pushing the boundary to make it more effective and easier for us to calculate the boundary or the perimeter of this shape. And we can see that this shape has a perimeter of 12 units. 3 on the left, 3 on the top, 3 on the right, 3 down below. 3, 6, 9, 12. Here we have an irregular hexagon, and we can change the shape on the left-hand side to a perimeter on the right-hand side. The way we do this is by pushing the boundary. We start off by looking at the green vertical line, and we move it out in our brain. We visualize moving the line, the green vertical line, to the left side. We push the boundary. We then take the horizontal red line and we push the boundary and push it all the way to the top. Now we can see that we have two rectangles that are exactly the same. They have exactly the same perimeter because we pushed the boundary out. So what we've done is we've changed our shape by mentally pushing the boundary out to create an easier shape to work with to calculate the perimeter. And we can see that the perimeter of our rectangle is 3, 6, 7, 8, 9, 10 units. 3 on the left, 3 on the right, 2 at the top, 2 at the bottom. Using our strategy of pushing the boundary, can you calculate what the perimeter of this shape is? If we move the 4 meters all the way up to the top and the 6 meters all the way to the right, what is the perimeter of this shape? We already know that we have 10 meters on the left side and 15 meters on the bottom. So what is the perimeter of this shape? Take a second to pause this video and calculate your answer. Hopefully you've had enough time now to calculate your answer. And we know that the perimeter of this shape is 50 meters. The boundary, the fence, the perimeter is 50 meters. If we walked along the boundary at one point and then walked all the way along the boundary and then came back to the start, we would have traveled 50 meters. So once again, looking at pushing the boundary out, we can see that we move the 6 meter edge out to the side, we move the 4 meter side out to the top, and we've pushed the boundary to create a rectangle. And here's our rectangle. If we calculate the perimeter once again, we have 10 meters on the left, and then we must have 10 meters on the right, 15 meters on the bottom, and 15 meters on the top. Therefore, we have a total perimeter of 50 meters.